Buddy, welcome to the first installment here of the Iceberg office hours here with the Dremio team. So we'll go ahead and what we'll go through today is basically a short presentation, about 15-20 minutes on copy on write versus merge on read in Iceberg. And which point you can ask, any questions about that, certainly about that topic as we go through it. You can use the Q&A function in Zoom here. Feel free to go through that and we'll make sure that we get those questions answered. But also, as we go through the presentation, if you have any other questions, or even especially afterwards, we'll have about 40 minutes for just kind of open Q&A, where you guys can just ask really any question you want. And to answer those questions, Alex, you want to go to the next slide? I'm Jason Hughes. I'm a director of product management running the developer advocacy function here at Dremio. We have Dipankar Mazumdar, who's also developer advocate, Alex Marced, who's also developer advocate here at Dremio. And then on the engineering side, we actually have 3 engineers who actually work on Iceberg here at Dremio too, Scott Cowell, Jonathan Bod, and Dmitry Borlashov. So with that, why don't we go ahead and jump into the presentation? Off to you, Alex.
Hey, everybody. My name is Alex Merced, and I'm a developer advocate here at Dremio, basically creating content, a lot of content, particularly around Iceberg every day. So hopefully you guys already follow me on Twitter and LinkedIn and have seen some of that content. If not, do follow me on Twitter over there at AM Data Lakehouse, always posting, again, great Data Lakehouse content. But today what I want to talk about is row level updates with Iceberg, because it's one of the many ways you can optimize your Iceberg table, okay? Bottom line is that Iceberg gives you a lot of features and a lot of flexibility to be able to tailor how a table behaves to your workflow, so that way you can get the best performance for your use cases. And one of those features that it provides is the ability to tailor how it handles row level updates. So basically, if you want to update one or many rows, delete one or many rows, run an upsert query, how these kind of queries are handled. Okay, and generally they're going to fall into one of 2 categories. So by default, a table is going to apply what's called copy on write, okay? And copy on write, what it does is that, let's say I update one record. So like, for example, right here, we have before the update, I have 6 data files: data file 1, data file 2, data file 3, data file 4, data file 5. I run a query where I update one or many records that are inside data file 003, okay? Well, what's going to happen is that it's going to rewrite the entire file. So there might be 1,000 records in that file, but I'm only updating, let's say, 3 records. It's going to rewrite the entire file minus the 3 records I deleted, and create data file 06, or with the updates if there are updates. So basically what you're doing is that each time you update a file, you're rewriting the file, okay? The pros to this is that it's much faster when you do a read, because basically all you have to do is read the file, okay? There's no reconciliation, there's none of these issues you have to worry about on the read side. But on the write side, you instead of writing 3 rows that you updated, you're writing the full 1,000 rows again. So basically, it can be a little bit more costly on the write side. So if you're running workflows where you're doing frequent updates, frequent row level updates, like again, updates, deletes, upserts, then you might want to consider merge on read. Now with merge on read, the idea is to avoid having to rewrite all 1,000 rows again, or however many rows are in that data file. Okay, so essentially, again, I have data file 03 and updating records in data file 03. So let's say, again, let's pretend I'm deleting or updating 3 rows. Okay, first now we'll just say delete 3 rows. What'll happen is that instead of me writing a whole new data file, so instead of creating a data file 6, a new data file to replace data file 03, I will still use data file 3 because most of it's what I need. But there are 3 records in it that I need to ignore. So instead, what happens, you create what's called a delete file. So it's like this companion file that says these records need to be ignored because these records have been deleted by a previous query. So benefit of this is your write is now a lot faster, because you're not writing 3 records in a delete file is much faster than rewriting 1,000 records or rewriting an entire Parquet file. So, but the con is that on the other side, on the read side, there is a cost, because on the read side, you'll have to reconcile that. You'll have to sit there. So basically on the reading side, it's going to say, okay, here's a delete file. I've read these 1,000 records. 3 of these I need to ignore. Okay, this 997 records are the records that are really part of this query. So there's that, depending on how you do it, that cost can be very small That cost can be larger. It depends on what your needs are, and we're going to get deeper into that. Although, one thing to note is that whenever you run like compaction jobs on your Iceberg table using the rewrite data files procedure, then that goes away, because anytime you do compaction, it will reconcile those files and write the new data files at the time of compaction. So then going forward, the reads are no longer affected because those delete files will have already been reconciled. So, but in the meantime, between compaction jobs, if you're running a lot of updates, a lot of deletes, doing merge on read can save you a lot of pressure on that right side so that we can meet your SLAs. Okay. But in the world of delete files, there are technically two types of delete files in the Iceberg spec. Okay. Right now, most implementations, most times when you use Iceberg, if you're using merge on read, you're going to be working with position deletes. Okay. Which are a nice balance between all the different sort of costs and benefits. But essentially, the way a position delete works is that the delete file tracks the row number or the record that is being deleted in that file. So it'll say, okay, hey, in this file, the 10th, the 15th, the 20th record are going to be ignored, okay, or deleted, okay. And the benefit of that is that it's going to be a little bit quicker to reconcile because I know exactly which file that goes with, and basically all those delete files are going to be organized by partition. So in that case, basically, if none of the records, let's say I do a query and the partition that I'm querying doesn't have any of these delete files because the things I've deleted in the past belong to a different partition, then it's not going to affect that query at all. So it's a minor so basically there is little cost on the read side. There is a little bit more cost on the write side versus the equality deletes. The reason being is that in order to determine which row you're deleting, on the right side, it still has to go read the data file to figure out, okay, this is the row that we're deleting. But the cost is, again, minor. So it's like the best sort of balance. Then there's equality delete. So basically, if you really need the fastest writes possible, and you're just really, any little amount of less work you can do on the right side, the better, then you have equality deletes. Because in here, what they're doing is instead of saying, okay, this particular row we're deleting, you're basically saying, okay, delete any rows, ignore any rows that have these values. So I might say, okay, delete the rows with the following IDs, 5, 7, 38, 50, 90. It doesn't actually have to scan any data files because it doesn't have to know which file they're in or anything like that. It just knows that next time we read, ignore any records that have the IDs of 5, 7, 38, 50, 90. But that does put a penalty on the read side because on the read side, then you don't know which data files that these records are going to be ignored. So you kind of have to scan through all the records to figure out, hey, where are these records that I'm ignoring? Generally, you're going to want to run more regular compaction so that way you don't have that cost when you're using equality deletes. Again, I would say like the vast majority of time, the vast majority of implementations you can see right now are going to be using position deletes, and equality deletes may not even be an option at the moment, but it's a part of the spec. It's something that you'll have more and more availability to use as things evolve. But those are sort of like the two options. So again, basically you can first choose how the table handles the updates, copy on write, merge on read. And if you're doing merge on read, you can decide how does it handle delete files, position deletes or equality deletes. And again, why would you be making these options? Because you're doing frequent updates. Frequent updates, deletes, upserts, where you're really working with like granular rows and you're trying to like optimize those write times. If the write times are fine as it is with copy and write, then just use copy and write, okay? Because then there's no penalty to read, none of that concern. But again, if you need to speed up those write times, then these are some options you have. And another great aspect of Iceberg is that it doesn't force you to have to make that decision for the table as a whole. You can be granular about when to use which strategy, okay? So you can actually set for each individual, whether when it's updating, when it's deleting, and when you're running merge queries, when it should use merge on read or copy on write. Okay, so you can actually set 3 different table properties. Write.update mode will determine which one it uses when you update a record. Write.delete mode will determine which one you use when you delete a record. And write.merge mode will determine which is used during a merge. And then any engine that is reading these Iceberg tables can then read these properties and act on them. Okay. And basically setting these table properties can either be done when you create the table. So if you already know you want to do this when you create the table, when you're doing your create table query, you can just set the table properties and then just basically set these settings to how you want them. But let's say you have a table that's been copy and write and you want to make some changes to how it behaves. You can then you can alter the table after the fact, because again, Iceberg provides you that kind of flexibility where tables can evolve. They're very flexible. You can involve your schemas, your partitioning, all the aspects of the table. So that way your tables are constantly able to meet sort of like what your current workloads, your current use cases look like. Okay, so just to kind of recap, sort of like which is which and the whys. Okay. Um, Copy on write. Again, copy on write is going to be sort of like the best balance. If you're doing like regular batch jobs or infrequent batch jobs, and copy where you have plenty of time to let the write kind of play out, and then copy and write's generally going to be, why not? Because then you have no cost to your read. If the write's going fine, then copy and write's the way to go. But the minute where you start feeling that tension in how fast your writes are going, then you're going to want to start saying, hey, can we optimize those writes, especially if what's happening in those writes are these granular updates, these granular row-based updates, where again, on copy and write, you're rewriting these entire data files. So in that case, we can clean that up with merge on read. And then typically, probably most of the time, you're going to want merge on read with position deletes. Like that's going to kind of do the trick. Okay. But again, if you're talking about like really, you need every little second, then you might want to explore quality deletes. But then quality deletes should be paired with very aggressive compaction, so that way you minimize that cost of reading as little as possible. So basically, you let the writes happen. Let's say you're batch, you're trying to meet like a 1 minute SLA, so you're ingesting every minute, and you're using these equality deletes. But then maybe every hour you want to run a compaction job, so that way you clean up the reconciliation the reads will have to do on those recent changes over the on a fairly regular basis, or something like that, depending on again what your SLAs are, what the dimensions of your particular job. But essentially, this is the world of like row level updates, which again is one of the many ways you can optimize your Iceberg tables to give you the performance that you need to meet your workflows. Okay, and along with the way Iceberg handles partitioning, the way Iceberg does min-max filtering, takes advantage of Bloom filters and Parquet files. There's lots of different levels at which Iceberg can kind of provide you that performance, and it gives you the flexibility to fine-tune those tables to give you that performance. So that way, because one size doesn't fit all, so really gives you that granularity, that flexibility to tailor it to your needs. And with that, I want to say thank you once again for coming out and joining us for our inaugural Iceberg office hours. Again, my name is Alex Merced. You can follow me on Twitter at @amdatalakehouse for all sorts of fun data lakehouse tweets on topics such as Apache Arrow, Apache Iceberg, Project Nessie, and more. With that, I'm going to pass it off back to Jason, and I'll be around.
Thanks, Alex. Thanks for going through that. So we've had a couple questions here. And so let's go through them chronologically here. One of them is from Brandon asked, can an Iceberg table be simultaneously listed in Hive and Dremio in parentheses Nessie? The use case is Athena and AWS Glue do not know about Nessie. They use Hive or Glue. However, I have Dremio and AWS and want the data as code experience. How do we make that happen? So the answer to that, it sounds like there's a couple questions in there. So the first one is that yes, an Iceberg table can be used simultaneously accessed by Athena, Glue, and Dremio. So if you use the Glue catalog for an Iceberg table, you can access via all three engines at the same time with no problems there. However, if you do want to use Nessie and have the data as code experience, Athena and Glue, if you're talking about the ETL aspect of Glue, that does not support Nessie yet. So you wouldn't be able to use all three safely using the data as code experience. Now, I say safely because you can have an Iceberg table stored in two different catalogs. But it's really not safe to do so, because then you're really storing that state of that catalog of like, where is the current metadata pointer? What's the current state of the table? There's definitely a possibility where if you're updating two different places at the same time and a reader goes in, two different readers at the exact same time accessing two different stores can actually get different answers. So that's why it's generally not safe. I mean, experimentation and everything for sure. If you're not doing updates that frequently, great. If you don't need that kind of like that granular level of safety, then that's also okay. If you have your writers committing to both, and you can have some sort of revert where the writer keeps state and knows that if the second write fails, to go ahead and revert the first one as well. So there's some considerations around that, but hopefully that answers your question. Yeah, so feel free to reach out. And of course, there is, of course, you are using Athena. If you are using Glue, like with a Spark on its own, if you run it on like EMR, does support Nessie. So you can go ahead and use like Dremio with Spark in that way. But yeah, Athena doesn't currently support Nessie, and neither does Glue, I believe. Brandon, feel free to follow up with another question if that didn't answer it. All right, chronologically. Sergio asks, does Nessie support the custom Iceberg catalog? I'm not quite sure what that means. Dimitri or Ajanta, do you guys know what that means?
Nessie itself isn't, yeah.
Go ahead.
Okay. Funny, we started with the exact same phrase. But yeah, Nessie itself is a catalog on the Iceberg side. So you have to choose which catalog you use. And Ajanta, feel free to continue.
Yeah, I think Nessie itself is a catalog, and it is like one of the custom catalog implementation which is available natively with the Iceberg itself. So yeah, I think that answers the question.
Yeah, for sure. Yeah, so just the clarification there is Nessie isn't really an engine. It does serve that purpose of the catalog, where other engines would use that catalog, like Dremio or other engines. Cool. Is Nessie catalog support in the Dremio OSS Docker container? It doesn't seem to work. Scott, do you want to take that one?
I think Dimitri or Ajanta's.
Yeah, okay.
Yeah, yes, it is true that it won't work as of now. We do have it in our roadmap. We are working on it. Yeah.
Mm-hmm. Cool, thanks. Alex, you have your hand raised. What's that?
Yeah, I just want to add one thing to the previous question. One thing to kind of consider. So if you wanted to use like Nessie and do some like custom work on it, one route you might want to explore is there's something, and again, Ajanta, Dimitri, correct me if I'm wrong, like there's like the REST catalog, which allows you to kind of build sort of like a custom like interface with using REST to Iceberg. So you could probably like basically create like a layer that interacts with multiple or keeps multiple catalogs in sync and apply it to that REST catalog follow that REST catalog spec. I mean, that'd be a bit of work, but I mean, that's one option I'm pretty sure.
Yeah. Go ahead.
As of now, I think the REST catalog is mostly an alternative to Nessie. I don't think it's easy to transfer from one to another, but at the lower level, there is a function in Iceberg that lets you import a table from another catalog. So that might work. But I don't think concurrent access is anything that can be supported at the moment. So,
well, I think it's supported, right? It's just not safe. Like there's nothing stopping.
Exactly. Right. No, nothing stops you. But yeah, if you want to, for experimentation, it's probably possible. For production, maybe risky. Yeah.
Yeah, right, for sure. Yeah, unless you want to put some sort of like locking at like the application layer or put some logic in there. But yeah, built into Iceberg, it's not a safe operation. Cool. Another question here is, does Nessie support multi-table data consistency committed? I think it's probably more just multi-table transactions, that kind of thing. Dipankar, you want to take that one?
Yes. The multi-table transactions, yes, Nessie currently supports that. And I think, we're probably like, putting out more stuff in there, like out there, like to see how we can do that. So we should see some more stuff on there as well. Yeah.
Yeah, for sure. You want to talk a little bit just about like how it achieves multi-table transactions in terms of like the model that it uses?
Yeah, basically, yeah. In terms of the branching level isolations and stuff, yeah, for sure, yeah. So yeah, Nessie allows you to like have isolated branching capabilities. So what you can do is basically, isolate yourself from the main production branches to ensure there is no impact on the data that you have in there. And you can do any type of like, data isolated activities like, ETL job, multiple distributed ETL jobs, updating the tables, or you want to do your own data experiments, whatever it is, you can separate that out from the Iceberg tables and have your own branch and do the things that you want to like on that own. So it really enables that kind of like separation and make sure there is no impact on the production workloads.
For sure. Yeah, thanks for elaborating on that. Brandon had a follow-up question here. He said, I thought Iceberg kept track of all commits inside itself and not the catalogs. Yeah, so that is correct. That Iceberg does keep track of all commits inside itself once you clean something up. But really the key is like the key is maintaining like what is the current state of the table, right? So if you have like V4, right, and you have in the Iceberg metadata files, you do have V1, 2, 3, and now 4 stored in Iceberg metadata files. But then you go create a V5, and let's say in Glue, you have, it says db1.table1 is pointing to V4, but in Nessie, db1.table1 is pointing to V5, right? Just for like just a half second or a split second, or for however long it takes your writer to finish that second commit. That's when you can have that state where you have this discrepancy. And one, it's bad on the read side because you end up with inconsistency, but it can also be even worse on the write side. Because if in between, somebody in Glue goes and writes and creates a new V5, which is completely different than the old V5, well, now you don't have a linear history anymore. You can't really combine those things. Unless you're using something like Nessie that builds that in intentionally. So that's really where that unsafeness comes in. And again, it's not built in. You can build things in the application layer like we used to with Hive for locking, with like the Hive table format. Like not Iceberg before, when we just like Hive and HDFS and stuff. You can build things into the application layer, your logic itself, if it's like the only one writing. But again, it's not built in. But again, it's fine for experimentation. It's just you end up with this safety issue. So if that's a problem for your use case, which is often the case in prod, but often can depend on the use case, that's where you end up running into issues there.
Yeah, and there is another aspect to that as well, because Nessie tracks changes holistically, where, for example, if you're making 2 updates to 2 different tables, in Nessie that would be represented. In Nessie, there will be a commit that contains both changes, and you can assume that if you're working with your data at that particular commit as presented by the Nessie catalog, then you have all the changes from both tables. However, other catalogs may view this completely out of sync, and there is no telling how the other catalogs may actually present that data. There is no guarantee even to the sequence of operations.
Mm-hmm. Yeah, good point. Cool. Thanks for the follow-up, Brandon. Let us know. Yeah, we can keep following up if you have if that answers it. If you have any questions, any other questions. Cool. Can Iceberg tables be stored on a NAS? Let's spread it around. Alex, you want to take this one? I think I'm surprising folks. Oh, Alex, you're on mute.
My bad. Oh, mute button. But generally, yeah, you should be able to store it on any kind of file system. So I mean, I've done it on just normal local file system. I've done it on Hadoop file systems. I've done it on object storage file systems. So you should be pretty flexible as far as where you can store it. The only, I don't know, I can't think of any particular considerations I would say in that situation. I'll open it up to see if anyone else has any specific considerations in that particular scenario. But I imagine pretty much any file system should be fine.
Yeah, I think that's the only requirement, is that you just need something that acts like a file system. Like you can't do it on like block storage, for instance, that like doesn't have a file system. You need something to act as the file system. So yeah, whether it's NAS or object storage or local file system or HDFS or whatever. Yeah. The key is that catalog. That's the other, as long as, and that's actually something we can maybe talk about here, is that you can even store the catalog on disk for like non-prod uses. So with NAS or even HDFS, you technically don't need a separate catalog, but for S3 is the main one that you do need something separate stored for that. All right. Ashok asked, can we use one catalog for writing, say AWS Glue, and one catalog for reading, say Snowflake? Yeah, Dimitri or Jonathan, you guys want to cover this one? Because especially on the Snowflake side.
No, I think Snowflake don't have a connector as an open source for Iceberg as of now. But if we keep, again, it goes back to the same problem. keeping the same table in two catalogs. So if we do some commits on the glue, it won't be reflected, or it is unknown to the Snowflake. So Snowflake may still give old data, whichever it was pointing to. So actually, there can't be any automatic refresh at the Snowflake side or at the other catalog side. So I think it's not possible.
Yeah, for sure. And I think the other thing to add there is based on the last time I was reading through the Snowflake docs, is that it doesn't even look like they support a non-Snowflake catalog. Like they store their own, they basically have their own internal catalog that only they can access and no one else can. So that's why they actually have an Iceberg. They can access Iceberg tables, but you see they also have like a syncing command where it says, hey, go out and get it. And so it's actually not quite up to, like, yeah, they can access it and everything, but they don't yet support, I would think they would, but start supporting some, like, you know, the most popular catalogs, right? Like Glue, like Hive, like those kinds of things. So I would imagine that's the case soon, I would hope. Cool. Let's see. What is the right combination catalog and type? Right now, REST catalog and type Hadoop breaks with S3, cannot load Spark generated tables into Dremio. Ajanta, Dimitri, or Scott, I'll let you guys see if you guys want to take it. If not, I have a couple thoughts.
Yeah, like if the question, if for like REST catalog right now, so Dremio doesn't support the REST catalog yet. We have that on our roadmap. So if you're creating tables on REST catalog, you wouldn't be able to access those in Dremio. If the data is in S3, you know, you could use typically, like if you have like we'll support things like Hive, Glue, or if you just have straight S3, you can use the Hadoop catalog. So and those would be traditional ways. If you want to share between Spark and Dremio, you could take those approaches.
For sure. I think the other consideration there is that I think with the catalog, using the Hadoop catalog on S3, it, like, you can make it work with like writing with the using the Hadoop catalog from Spark into S3. And you can use that Iceberg table in Dremio. You can promote it and it'll work. But that's generally not a safe operation, because S3 doesn't support basically the compare and swap atomic operation to actually update that pointer. And so that's why, especially on S3, which is actually where Iceberg, you know, originated with Netflix, which is why this whole concept of a catalog exists. That's when you generally want to, the easiest is usually Glue, because it's hosted for you. And then so if you were using the Glue catalog, which is supported in Spark, so you can take Spark, write Iceberg, like the data and the metadata files all to S3, and then use the Glue catalog. And then actually once you write that in Spark, then same thing, hook Dremio up to that same Glue, and we'll be able to read those Iceberg tables as well. But yeah, I haven't seen the REST catalog be, it's relatively new. Like it looks pretty cool and pretty interesting, but yeah, it's relatively new as far as engine and tool support goes. Cool. Ashok asks, Snowflake Iceberg table doesn't support partitions, so I'm forced to use some other catalog where the iceberg.parquet files are partitioned. Now because my EDW is in Snowflake, I have to have the Iceberg catalog in Snowflake. Now my workflow is I used Hive Metastore to copy the files over to S3. It's ugly, but okay for POC. Yeah, it makes sense. Yeah, and that's the aspect. This is the follow-up, guys, from one of his questions about Snowflake. Yeah, makes sense. That's kind of the unfortunate situation right now with Snowflake. Again, they're pushing pretty hard into the Iceberg. I would be pretty surprised. Well, not pretty surprised. I would be fairly surprised if they didn't end up supporting some sort of external catalog like Glue or Hive or whatever it may be. But yeah, currently that is what you would have to do. To do that, I think there is a command in Snowflake where you can sync it so you can maintain an external catalog. Maybe it's just an S3, actually. I don't recall off the top of my head. But yeah, that makes sense. Especially that, yeah, it's ugly, but okay for POC. Yeah, I'd be interested. You probably talk to Snowflake. I'd be interested to see what their plan for support is, because that's one of the key parts of Iceberg, is having this open nature where anybody can read and write. You have freedom of tools, and having a proprietary catalog store is kind of the antithesis to all of that stuff. Okay, cool. Next question, Sekar here is, are there any benchmarks that I can look at for update and read performance with Iceberg, be it using Spark, Athena, Dremio, etc., as a compute engine? I'm curious how the performance compares between a data warehouse, for instance, Snowflake, and a data lakehouse, for instance, Dremio. Currently, no, but this is actually something that we are looking at right now. Is actually doing this comparison to make sure that, certainly looking at the different engines. I think different engines on Iceberg is largely going to be really more of a symptom of that engine. Like Spark, right, is what they're built for. Like Spark was built as a replacement for MapReduce. So it has some resiliency and things built in that it needs for long running jobs. So it's not really built for interactive querying, right? Versus Dremio, which is very much built for interactive querying. So that's where you'll generally see that. Like, I think it really comes down to, like, if you're running, you'll see it even if, come out with the benchmark. If you're running something that needs to be an interactive query, well, then Dremio and Iceberg are going to be your best bet. If you're running something that needs to run for 12 hours, 16 hours and not fail, you need to be sure that it won't fail, or it'll take just one more hour instead of having to restart the whole job. That's where Spark on Iceberg is really it. And that's the nice thing about Iceberg, is that all this stuff is really engine independent. And generally most of the engines support most of the Iceberg stuff, at least the really key stuff around, like, partitioning, hidden partitioning, that kind of stuff. As far as the last question, performance compared between data warehouse, Snowflake, data lakehouse, Dremio, we are also working on a benchmark comparing that, like, independent well, we'll probably include table formats like Iceberg, but yeah, we've run one recently and we're trying to get it external. But yeah, that basically shows the performance between those two. Hopefully that answers your question. Feel free to follow up if it doesn't. Anonymous attendee, hello, asks, for multi-table transaction consistency, the NESI catalog must be used only. Yeah, correct. One, that's the two sides to that question, I think, is that, yeah, correct, you can only use one catalog. But two is that, yes, no other catalog currently supports multi-table consistency. So if you want to do multi-table transactions on the lakehouse, on your data lake using Iceberg, the only catalog that you can use for that right now is NESI. And it's actually, yeah, go ahead.
Yeah, just to expand a little bit on this. So NESI will allow you use cases, to have use cases like, for example, branching. You could use branching for this. So you may want to branch off your main data, the main state of your data, to then do multiple changes to multiple tables in your branch. Be sure that you're good with the data, that the data is valid. Use your own validation tools. Once you're happy, you can merge it to your main branch, and then you have one commit that represents the whole set of changes as one atomic operation from the NESI's perspective.
Yeah, thanks for that color. That's helpful. Now here's a question that I was kind of waiting to get the whole time. From an anonymous attendee. Our team is currently using Delta Lake, but considering switching over to Iceberg, how frequently do you see customers make that move, and why do they move? And how long does it take on average? Obviously dependent on a few different variables, yeah, for sure. So on that one, basically, we currently are engaged, so at least on the Dremio side, obviously there's a lot of other vendors that work with Iceberg, but at least on the Dremio side, we certainly have a lot of customers come to us and prospects as well. Talking about Iceberg and are interested in it, at a minimum are interested in it, if not POCing it, if not in a transition right now. I will say that, the biggest, well, there's a few reasons why they move. One of the big ones is that they really see Delta Lake as another lock-in, because Databricks controls the direction of the project. So we've even had, I was on a call with a customer a month ago or something like that. And they even said, like, yeah, we see Delta Lake as just another lock-in like Snowflake. Like, yeah, they say it's open source and they did it once. but then it's still not open. And then it wasn't open source, and then they said they did it again, but it's still not open source fully. And just the incentives aren't there. So that's straight up what they told us specifically. So that's one of the big reasons, but there's also some other features, and they really see the adoption and the diversity of the thought, and really diversity of the contributions of where you have a lot of different people that have a lot of different requirements, basically producing additional or contributing additional things, right? Like you see this happened with like Parquet, where like a lot of people are using it for different features, and like big tech companies, you know, were actually able to contribute things themselves based on different needs, right? Like some companies have no need whatsoever for geospatial. Other companies absolutely need support for geospatial, right? So there's actually a support being considered right now that it's already, you know, PR open for geospatial as an example, right? So that's another big one. There's also some features in here that actually are that Delta Lake doesn't support that Iceberg does. Alex, do you want to talk through those?
Sorry, I was just answering one of the questions in the back.
For sure.
So what was the
talking about? So I talked about kind of the first part of his question around like kind of the more the higher level around why companies with the Delta from Delta Lake to Iceberg. Do you want to talk about some of the features that Iceberg has that Delta Lake doesn't?
Oh, okay. One of them is what we just talked about at the very beginning. Right now, Delta Lake still doesn't have the ability to do like to tailor, like do merge on read and other kind of row level updates. Another feature that I find one of my favorite features is of course like the hidden partitioning. And just to kind of like Delta Lake does something similar, but there are some substantial differences between the two. So let's just kind of like talk about first what the feature is in Iceberg, and then we'll talk about what the feature is in Delta Lake and the differences. So in Iceberg, when you have like hidden partitioning, essentially partitioning is tracked via a transform. So instead of saying, okay, hey, I have this month column that's based off this timestamp column, and I'm partitioning based on that month column, you just partition based on the timestamp column. And then Iceberg says, okay, you told me that you partition based on this column if we transform it into a month number. And you can also do like month, day. You can also do truncate. So if you have like a string field, I can say, hey, partition it based on the first letter of the first name. Or I can do buckets where just say, hey, partition it into like 16 arbitrary buckets. So you have all these options, but they don't create a second column. So one, you're reducing like what you're actually storing far as data, because there is no need to store an additional column in the actual Parquet files. All that's tracked in the metadata, where it'll track that partition value. Basically is going to allow it to kind of determine that partitioning a lot better. Now, in Delta Lake, what they do is they do something called a generated column. So you still are creating an additional column. So all those Parquet files will have an additional column. So you are increasing the amount of writing when you use the generated column. But what it'll do is it'll automatically generate that additional clause in your query. So if you have this generated month column and you query the timestamp column, it'll still kind of automatically kind of figure it out. But again, you're still writing that extra data, and you're still having to go wait to get to like the actual data files to kind of do a lot of that additional what's the word I'm looking for? Additional filtering. While Iceberg, you can filter from the metadata, because the metadata is what's tracking those transformed values. So like that I find like super cool. Also just like some of those transforms make for some really interesting partitioning patterns, particularly like using truncate and bucket and whatnot. Also the dependency on sort of the file structure, the physical file structure. So basically if we're using like Hoodie or Delta Lake, they really do kind of still depend on the way they track the metadata, and the way they track the different snapshots still depends on sort of like that underlying file structure. So like in Delta Lake, you have all these like snapshots. So you have your Delta logs, which are just saying that we're kind of like git commits in the sense where like each Delta log is just like the Delta of the previous log. But basically it's depending on all the files being sort of in this directory. So it'll be like, okay, hey, all the data files are in this directory. Here are my Delta logs. Let me reconstruct which data files I need by going through each Delta log and seeing what the list is at the end of all the Delta logs and checkpoints. Iceberg basically is working off just the list of files that are in the metadata. So it doesn't matter that the files are in the same directory. And this allows you to have some patterns where, especially on S3, you can avoid some of the throttling, because on S3, they'll throttle you if you have too many requests in the same prefix. So having all your data for one partition in one folder can result in a reduction in the speed of a query, because you have throttling over many requests. Iceberg, because it's not dependent on that physical structure of the files, it can avoid that. So for example, if you're using Dremio to write an Iceberg table, you'll notice that like it creates all these like hashed name tables in your S3 because it's distributing those files so that way it gets best performance on S3 possible. And then if you're running it from Spark, you can turn on compatibility mode in the Iceberg settings, and it'll do something similar. Those are just a few of the things that kind of like are unique to Iceberg that make it like super cool, and reasons why people like it, especially particularly if you're using like object storage. Again, I think the partitioning is a big deal because if you with good strategic partitioning, I mean, Iceberg really can accelerate your queries. And again, you're reducing the amount you're storing because you're not writing that extra column or extra columns, depending on how complex your partitioning is. So there is a lot of benefit. So I'll leave it there because I know there's like other questions.
Cool. Thanks for going through that, Alex. One of the other questions on here from Ashok was, do we have any reference config settings for Spark to Iceberg to S3 with Hadoop catalog? Alex, Tom, could you guys want to paste something in the Zoom chat?
Yes, I did. That was the question that I was actually answering when a second ago. So I did send a link over, and then so I did paste that link, and then I'll see if there's somewhere else. I'll paste it in. Can everyone see the chat?
Yeah, everyone can see the chat. I think the Q&A,
okay, so
but maybe they can't.
Okay, so I'm gonna post a link in there so that way everyone can see it. And then this link, there's an upcoming Python article I'll be doing. So a link to this will also be in that Python article, along with a lot more detail on like all these different possible configurations. So keep an eye out for that in the next couple of weeks. That'll show you how to configure pretty much any catalog you want in the Spark settings. With Dremio, you'll get it to. Let me do that at everyone. Oh, I see. A moment. Send this thing to everyone. I don't see that option. Yeah, I don't see that option. But basically, you'll be seeing that in the Python article that's coming up real soon. And I do have, again, this reference file on this markdown on GitHub right now that actually has a good chunk of the potential different configurations. And so that way, it's easier to figure that out because there's so many different possible configurations, particularly with the Spark, that it gets kind of confusing knowing, okay, when do I set it to Hadoop? When do I set it to Glue? How do I set up the Dynamo catalog? So this should make life a lot easier.
Cool. Thanks, Alex. Cool. Brandon had a follow-up question. I gather the only realistic way to load Dremio using Nessie catalog is with Spark and support libraries. How do people use the Iceberg tables then with other tools? It sounds like they would need to constantly tell their external tools to recheck the Iceberg tables for the latest command. Yeah, I think there's a couple aspects here. One of which is whether you just want to use, if you're specifically talking about, well, I guess let's take it the generic way. If you're just talking about using Dremio with Iceberg tables and using Iceberg tables with other tools. Like the Hive catalog, I think is supported just about every tool. I think the Glue catalog is also supported just about every tool. So is the Hadoop catalog, and if you're using ADLS or GCS or HDFS, that can be more okay than S3. So those three are at least, and then Nessie, I know that there's work in progress to support it in other engines as well. But correct, if you're going to use Nessie right now, Spark and Dremio are going to be your main ones right now. Now the key is that we have work in progress to actually get it supported in other engines, both from the open source Nessie as well as we're also approaching it from the Dremio Arctic approach, which is just all the APIs are the same, it's just hosted Nessie. So we're also pushing it that way. So basically the equivalent is that we're pushing and getting it incorporated into other projects as well. So right now you're basically, you can only use it with Spark and Dremio. But you can basically get that in. There's not the aspect of lock-in because we are going to get it supported in other tools if you want, right? Usually Spark and Dremio is a very common combination that we see. Spark more for ETL and like ML stuff, and even streaming stuff, and then Dremio more for the interactive and the read side for user-facing stuff. But yeah, you can use you can also load data in the Nessie via Dremio Sonar. Using like CTAS and stuff like that. But Jonathan, Dimitri, anything else to add to that?
I think Flink is pretty well supported as well at this moment.
Nice.
Yeah.
Presto also can work with the Nessie. Trino is just work in progress.
That was the one. Okay. Cool. Awesome. So yeah, you have another streaming engine with Flink, and another ad hoc analytics tool with Presto. And Trino is work in progress. Cool. Thanks for clarifying that. So as Glue is AWS, we want only on-prem stuff. Raghav, I think he was talking about the catalogs. Yeah. So Dimitri, Jonathan, you guys want to talk about some of the on-prem catalog options?
We have Hive catalog where we can run a Hive metastore on-prem, and we can connect it with the multiple engines. I think that is the only main on-prem cluster which is widely used.
Yeah, for sure.
Nessie itself, you can use open source Nessie and run it on-prem. I think a number of backends is supported, like Postgres, H2, Dynamo, Mongo. Yeah, you can check the open source for the full list. And yeah, so that will give you a Nessie catalog on-prem, and you can hook it up to any engine you want. If you want to hook it up to Dremio, that is still work in progress, but we hope to release it soon. So you'd be able to use on-prem Dremio plus on-prem Nessie soon. And you can use it with Spark even now.
Mm-hmm. Yeah, and then the one other thing to add there is that if you're looking to you can also use the Hadoop catalog with like HDFS. It's not fully recommended in prod, but you do have some consistency guarantees. I think maybe Jonathan or Dimitri, do you guys want to talk about the considerations there around like when it can make sense to use the Hadoop catalog on HDFS versus when it doesn't? I
think we need to use the Hadoop catalog with a lock manager. Without that, because it relies on the underlying file system for atomic rename operation. Like whenever a table metadata updates, it just does a atomic rename to keep the latest state of the table. So it widely depends on whether the underlying file system, which is used by the Hadoop catalog, can it support atomic rename.
Yeah, for sure. Thanks for clarifying that. Cool. The next question from Francis is, do you see performance impact between Delta Lake, Hoodie, and Iceberg on S3? Dipankar, you want to talk about that one?
I don't know, like in general, like we obviously we haven't done the comparison in terms of how it like impacts the reader write from S3. But I guess like in general, like, there is a difference in terms of like, obviously like the S3 has like consideration in terms of how we can probably, see more like, threshold improvements and those kind of stuff, and those kind of bottlenecks that we deal in general. But I'm not particularly sure in general, like how it impacts with like those three table formats. I don't know if anyone else has done that comparison, but from a practical point of view, I'm not really sure. Like,
yeah, for sure, fair enough. So I think from my perspective, it's that so in general they should be pretty similar with a couple considerations. One of which is that, and they're all really use case based. One of which is that, as Alex mentioned before, that Iceberg has merge on read, whereas Delta Lake doesn't. So if you're doing like a bunch of streaming updates, and like you really want to do like even to the extreme like equality deletes, like Iceberg's going to be way faster for the write side for that, right? But then you might have impact on the read side, right? But it depends what trade-off and where you want to sit for each use case. But that's an option that you have with Iceberg, is that you can do the you can actually do merge on reads with even equality deletes to really save, you really get your data freshness up. But if you really want performance, then certainly you can use copy on write, and that should be about the same for all of them. The other difference, and again, most of it would be the same outside of these two things, is around Iceberg's object storage file layout that Alex alluded to as well before. And I think Dipankar mentioned there about the throttling that S3 does per prefix, and actually just about every, I think, object storage does throttling, or at least the unit of parallelism is the prefix. So that's where they actually do the sharding there. And so that's where, if you're accessing like a lot of files in one partition, but either on the read or write side at high frequency, or even for a single query, sometimes if you have enough data, that's where you can see throttling. S3 will actually start throttling you if you're using Delta Lake or Hoodie, whereas it won't with Iceberg. So I'd say that those are the two big differences. Other than that, if you're not in a situation where that where either of those make sense, it's going to be pretty comparable. Like there was a benchmark which you might be alluding to that came out, I don't know, a week or two ago that showed like Delta Lake's performance way better than Iceberg. But it turns out that if you actually look at it, they decided to use a feature that Delta Lake has that Iceberg has but is not on by default, which was basically the repartition before you write. So they ended up writing a ton more files because they never told Iceberg to repartition it, which is on by default in Delta Lake, but not Iceberg. And then they explicitly chose not to use merge on read because Delta Lake didn't have that, even though that would have been an advantage for Iceberg. So again, it's trade-offs like that. But in general, it's going to depend more on the engine than the table format itself, outside of those two things I mentioned with the merge on read and the object store file layout. Brandon, do you know if the Iceberg Java APIs are comprehensive enough to read and write data rows to tables that could be added later to a catalog? Jonathan, Dimitri, you guys want to take that, or Alex? I saw your hand up.
I think whatever the Java API is there, it has to work with the catalog itself. We need to make a catalog instance first, and then from the catalog we can load the table. With that, we can do the read write operation. So it cannot work independent of the catalog. It is dependent on the catalog itself.
So essentially, just to add to what Ajanta said, if you make a change outside of the catalog context, then the catalog has no way of knowing that there was a change, and then you can diverge your history from the changes coming through the catalog, and you'll have to reconcile it after that, which can be pretty difficult to do.
Cool, thanks. And then if the question was around specifically just, I think they answered what you were getting at, but just in case it's the edge case, is that, yeah, so basically a lot of the engines use the Java APIs. So anything that the engines can do, like anything like a custom Java application you can do too, if you just want to invoke those APIs yourself. What is the preferred CDC capture streaming process from RDS, Postgres, schema table data into S3 Iceberg tables? Flink CDC connector, Debezium, or Kafka Kinesis? I mean, I can go quickly and see if anybody else has thoughts here, but I think it largely depends on your use case and what tooling you have. Like if you have Debezium already, well, then it works pretty well to just use Debezium. If you have Kafka and you don't want to put in another tool and you want to just use something like Kafka Connect, there's a Kafka Connect connector out there that you can leverage. Flink as well. I think it's largely the same thing. I think Flink is probably more robust if I had to guess, because it's been around longer and a lot of other big tech companies use that more. But I'll open it up, see if anybody else has any thoughts or additional color there. Okay, cool. Yeah, just to wrap up, like, yeah, all three of those can work. It's more about, your personal considerations. About a lot of it has to do with, like, do you want to spin up another tool? Or if you already have one of them, great, probably use one of those. How do I change the write properties of Iceberg tables? More specifically, change the value of write.parquet.compression-codec property from default gzip to zstandard in PySpark. Ajanta, you want to take that one?
Yeah, I think we have an alter table properties, so we can use that equal from the PySpark also. Also, we have Java API to alter the update table properties. With that, we can specify this value. I can give a link to some Spark documentation in the comment now.
Great, thanks. And then Brandon asked, which might be the last one that we have time for here. What are the minimum requirements for adding support for reading, updating, and writing to a Java-based ETL tool? Specifically, I'm looking to add support for Iceberg tables to Apache Hop. Jonathan, Dimitri, Scott, one of you guys want to take that one?
Yeah, I can cover it briefly. So for For reading, it's pretty straightforward. You can just use the Iceberg Java API. They have a nice scan planning API, which will let you essentially ask Iceberg, hey, I want to go run a query, and you can have provide some expressions for partition pruning, for example, I believe. And with that, then it will give you, essentially, you'll ask Iceberg, hey, tell me what data files I need to scan. It will give you essentially a list of tasks, like file scan tasks. And then assuming you're doing your own file reading, you can go then, call into, assuming you have like existing Parquet readers or something, you can pipe that into your existing scan logic. Alternatively, they have classes for reading Parquet files. Like, I'm less familiar with those because we don't use them internally in Dremio, but that's an option too. And then for write, it's a little more complicated, but essentially you can go figure out what are the changes you need to do to, say, underlying Parquet files, go do those writes in the normal way you would on, say, just like a flat Parquet table. Then once you've got your, say you're doing like copy on write modifications, you've done those modifications, have a new set of data files. Iceberg has a set of write APIs for operations like, say, I can do a append of new data files to a table. So they have a append transaction operation, or I can do overwrite operation, which is essentially, okay, I'm like doing copy on write overwrites of files. So depending on what you're doing, whether it's inserting new data or overwriting existing, you'll use one of these table operations. And then the API will let you go apply those where you're telling it, here's the data files I'm appending or overwriting. And then you can call into Iceberg and say, commit these changes. And then Iceberg will do all the magic of making sure, okay, given the catalog you've connected to, it's going to go update the root pointer, update all the metadata files, et cetera, for you.
Cool. Thanks for that, Scott. Yeah, so Brendan, feel free to follow up if you have if you have any follow-up questions on that, or you can email us directly, because we're actually about out of time here. Yeah, if anybody has that or any other follow-up questions, feel free to reach out to us. You can actually reach out to all of us at tech-advocacy@dremio.com, or direct to me at jason at dremio.com. Some of us on Twitter if you want to come find us there, LinkedIn, of course. But yeah, thanks for all the questions, everybody. Definitely really appreciate it. And we'll see you next time for the next installment of Apache Iceberg Office Hours. Thanks, everybody. Bye-bye.